Hello everyone, welcome back. Today we're gonna start doing chapter 14. Chapter 14 we're gonna do binomial distribution, and we've been doing this since the year 11, but that's okay. We can start refresh a little bit and then give you guys ideas how we're gonna do with binomial, Bernoulli sequence and binomial probability distribution. So Bernoulli sequence is actually similar with distribution. The sequence repeat trails with the following properties. So we with the actually three tips. So each trail result of one of the two outcomes. So which is either success, either failure. So and the probability success single trails we call P, and constant all the trails probability of the failure on the single trail is called 1 minus P. So either success, either failure, so which is 1 minus. The trails are independent. So the outcomes, any trails are not affected by the outcomes by any previous trail. So as we know this knowledge and we can do some questions like that. So suppose a netball player has a probability of the 1/3 of the scoring the goal each time they attempt to the goal. So she repeatedly the shots for the goal. Is that the Bernoulli sequence? So first thing first, each trail is actually result of two outcomes. Result of two outcomes. So either go or miss the shot. So tick. And secondly, the probability of the score. So probability of the goal are equal to 1/3, and is constant for all the attempt. And the probability miss. So miss of the miss shot. So probability of miss will be 2/3. So tip. And then the trail are independent, so which is not any trails are affected by the outcomes from previous trails. So independent trails. So this is Bernoulli sequence. Perfect. All right, so Bernoulli probability distribution, so which is we using random binomial random variable, and then we can say the number of success. So the first thing first, possible outcomes for rolling the so I guess this one is rolling the probability for 3 rolls, and the outcomes T is representing the number of wait. So I guess it's the number of threes. Um, so what's a T are representing? What is this means? So I guess it's about the 6 dice and random picks, and the T success means you rolling a number 3, and then so N representing not 3. So I guess. So each one is like 1/6. So there's a fair dice, and then you just rolling. And if you 3 outcomes or both is a 1/6, that means this a successful 3 times. And then that just multiply by each time because remember it's independent. So and this is outcome for success for 2. 3. So, but 1 is like 5/6. So, what's 5/6? Because you are you failure to rolling the 3, so which is 1 minus 1/6. So that was 5/6. And this is a probability for 1. So you had two outcomes is n, so which is 5/6, but you multiply by 2 times, and then which is you using the square, and then you doing 1/6. But this is 3 outcomes, so which is you multiply by 3. The last one, which is a 0 outcome for 3, so which is this is the most possible one. Yeah, and you come up with this table. Then we call this one is called binomial distribution. So that's pretty understandable. So first thing first, we say the binomial distribution, the n are representing the independent rows, how many rows we have, and p are representing the probability for success, and 1 minus p are representing how many times you had without a success. So what's the x are representing? This is I want you guys to understand that x is means that maybe success once or twice or 3 times. Okay, that could be anyone. So put this one to your bound reference, and hopefully that makes sense for you guys. Now I'm gonna write this one with my CAS calculator. So first one, we're gonna 3 heads and a fair coins toasted 7 times. So we're gonna say the 4 decimal places. The first one first. So first thing first, I'm gonna try without a CAS calculator to write the way to write how you do the binomial distribution. So the heads is success. So probability of heads is equal to 1/2. And which is the 1 minus the p will equal to 1/2 as well, so that's equal to p. Because you rolling the 7 times and equal to 7, so this is all you need to know. And then because you do the 3 heads, so which is exactly 3 heads, so which is we do probability of x equal to 3. So that means 7 rows and exactly equal to 3. And we multiply by half to the power of 3 and multiply by half 7 minus 3. Yep. And the second half is 1 minus p. Okay, so just be aware. Yep. So here is the using the CAS calculator. So you have a 7 rows. Probability success is 0.5, x value is 3, and then that's how you calculate it by CAS calculator. So I show you in the class menu, probability, distribution, binomial PDF. Later on, we will do the binomial CDF, and that will be showing you the difference. Okay, here is. Now we talk about the CDF, and now let's start what's the difference between those two. First thing, the probability of that person currently in the present and has never been there in before is like 72%. Find the probability that 5 prisoner and choosing random at least 3 have been in present before. Exactly. So first thing first, we need to write the x is a number. We don't know. So probability of x equal to a little x. So we say 5, and we find out 3, we don't know, and then 0.72 is our success, so x, and then multiply by 1 minus 0.72, 5 minus x. So this is our binomial distribution, but they say at least 3 times, which is the probability of x are greater than equal to 3. So that means we are using probability of x equal to 3 plus probability of x equal to 4 plus probability of x equal to 5. So we're gonna rewrite this 1, 2, 3, 4, 5, and then we put up into this into the binomial distribution. So, but we can say we're gonna using the 3 times, so we can't do by hand. But we're gonna I can rewrite a little bit, so we can write this one too. A probability of x greater than or equal to 3 are equal to 5, 3, 0.72 times 3, 0.18, sorry, 28 times 5 minus 3 plus 5, 4, 0.72, 4 and times 0.28, 5 minus 4, and then plus 5, 5, 0.72, and 0.28 to the power of 0. Yep. And here is the CDF things. The CDF means we have to show them the low bound to the upper bound. So here is number 12 and success, and the lower bound is 3 because at least it's 3, and upper bound is 5, is maximum is 5. So this is how you show. And then later on you can say, if you select the random 5 people, 3 at least 3 is in present, it's like 86%. Yeah. So now we're gonna try to do with some binomial distribution. So first thing first, the probability of the netballer scoring is 0.3, then which is if you not score is 0.7. So first thing first, n equal to this is 6 attempt. So 4 times we know, which is we're gonna say x equal to 4. So a are equal to probability of x equal to 4. So that equal to 6 to 4, and 0.3 is score, which is success 4 times. And then 0.7 is 6 minus 4, and that equal to 2. And then we calculate it, and that approximately put in the CAS calculator 0.0595%. Sorry, not percent, it's like, yeah, that will be 6% approximately. Yep. And question B, so 4 times given at least 1 goal. So now we're gonna use independent events. So probability of x equal to 4, but given by x greater than or equal to 1. So which is at least 1 goal. So that means you say probability of x equal to 4 and union probability of x greater than 1 over the probability of x greater than 1. Please use the CAS calculator. The first one is easy because on top we can say you are equal to 4, but you are also greater than or equal to 1. That means probability of x equal to 4 over probability of x greater than or equal to 1. Okay, so now what we do is, what is the probability of x greater than or equal to 1? That's the question. Can we just say it's like 100% minus the probability of 1 goal? Because you're never going to score the 0.5 in the netball. So that means 1 minus, let me think, because you are success once, but you're missing 6. So which is, you can test out, it's like, you see 6, 1, 0.3 to the 1 times 0.7 to the 6 minus 1. Yep. So, and once we get that, then we can say that equal to some numbers. Please use the CAS. And later on, that will equal to 0.0675. So this is given by. Yep, Perfect. And use CAS calculator, and then I'm gonna show you how we're gonna do it. This is all I need to say. Hopefully they enjoyed it. I'll see you guys next time.